Hello and Namaste. In continuation with the linear programming problems, we are discussing with the Simplex method, and after the detailed discussion on the maximization type, we are going ahead and I'll be explaining you with the minimization type of question. Now, the question is minimize z equals to minus 4x plus 2y subject to the constraint. So we have been given two constraints and there are two variables. Now rather than to give x1 and x2, they have given us x and y. So we'll be not changing this x and y. We'll be keeping this x and y as it is. We are not going to go change the label whatever the given in the question. So now since the problem is that of the minimizing the objective function, we can convert it into the maximizing by multiplying z equals to minus 1. So minus z is nothing but maximizing z dash, or sometimes it is also known as z star. So but here we are calling it as z star. Sorry, z dash. Z dash is nothing but minus of z. That is, this minus 4x plus 2y can be written as 4x minus 2y. And therefore, just to have this particular question and this standard form, we can write down the standard form as z dash is equals to. Now again, we have been given first and second constraint, though two constraints, and both of the constraints are less than or equals to type. So we have to include here s1 and s2 as the slack variable. So in the first constraint, we are introducing s1. So as soon as we are doing it s1 here, we have to do the same thing in the objective function with the coefficient as 0. Same thing we have included now, as I have told you last time also, that this is what I have included here in this particular question. So this s1, as soon as we are including in the first constraint, we have to include it here in the second constraint with the 0 coefficient. It is not mandatory, not compulsory, but yet yes, it will gives us the to write down the particular matrix or fill up that particular table very simple and easy way. Similarly, we are taking at s1 is greater than or equals to 0 as the non-negativity constraint. Again, in the second constraint, we are introducing here s2. As soon as we are introducing s2 over here, we have to introduce here s2 in the objective function with 0 as the coefficient, as well as in the first constraint with the 0 coefficient, and in the non-negativity constraint for the s2. Now, after putting, again, we have to find out the initial basic feasible solution. We have to put the decision variables x is equals to 0, y is equals to 0 here. After getting that, we'll be getting the initial basic feasible. S1 is 18, S2 is 6. Let me write down, this is this in the next table or next slide over here for the initial table. Now in the case, as we have filled up the table in the last case, the same thing we are going to do it. So the coefficient, this is x, y, s1, s2 as a variable RHS, and this is theta or a ratio. These are the CBs or the basic variables, the coefficient of basic variables in the objective function. And this is CJ, which is the coefficient of basic the variables in the objective function. So now here, the coefficient of x is 4, coefficient of y is minus 2, this is 0, this is 0. Now we have got, as I have told you, this s1 and s2 will be the part of basic variables in the basis. So we will be getting s1, the coefficient 0, coefficient 0 here. To get the first constraint here, we have to write down the variables, the coefficient of them, that is 6, 2, 1, 0, 18 as the RHS. We have already seen this type of how to fill up the table in the maximization kind. So what we are doing here maximization only, though it is of minimization, because we have said that minimization is nothing but maximization of maximum of maximization. So what we are going to do it, we are going to find out the maximization of this particular question, and then we'll be saying the value of minimum. Now S2 is 3, minus 2, 0, 1, 6. We have to calculate Cj minus Zj's over here, the way which we have done it here. Again, the CB's for this particular step is 0, so obviously we are going to get directly same as that of Cj's. So that is 4, minus 2, 0, 0. Most positive or biggest positive for Cj minus Zj is this. That means this first column would be the key column. Which variable will leave the basis? That would be getting decided by RHS divided by this variable x. That is 18 divided by 6, that is nothing but 3. Then here next is 6 by 3, which is 2. Now out of 3 and 2, 2 is minimum. So the first, or you can say the S2. Sorry. Okay. So this will gives us here, just a minute. So second row would be the key row, and this 3 is the pivot element, or you can say the pivot element is 3. Moving, so this is what about the initial. Now moving ahead with the table, this particular thing, I have already kept this table as I have told you that S2 is getting replaced by X, the variable X over here. So this is getting in, this is going out. So this is the particular second row would be the R2 new. Now what this particular R2 new will give you, this 3 has to be 1. To get this 3 has to be 1, we have to divide the entire second row by 3. After dividing this entire row by 3, we will be getting as 1, it's minus 2 by 3, it's 0, it's 1 by 3, it's 2. Right? This is what the second row we are going to get it. Of course here this is 0 and this is the coefficient for this is nothing but x4. So it's 4, I have not written here, just a minute, let me complete it. Okay, so now here to get this first row we want this 6 0 using this 1. So what would be the transformation? That would gives us R1 old minus 6 times R2 new. So that would give us 6 minus 6, that would be 0. Next is nothing but this 2 minus 2 times minus 2 by 3. That will gives us here the value of this particular is 6, then 1, then minus of 2, and then RHS is coming out to be 6. Again we have to calculate this Cj minus Zj is the way which we have done it previously. So it's 4 minus 4, that would be 0 here. Then this is nothing but it's Cj minus, so minus 2 minus this 4 into this minus 2 by 3. So that would gives us over here as 2 by 3. Then this is 0. This is giving you the value as this is 6. Okay, the Cj minus Zj over here would be equals to 0 minus 4 by 3. So it's a minus 4 by 3 over here. So now out of this all of them 0, Cj minus Zj, this 2 by 3 is the only positive we have got it here. Because of this particular column would be the pivot column, and if you'll observe the second element is minus, so we are not able to consider the theta for this or ratio for this. So we have to take the theta for the first one, that is 6 by 6, that is 1. So obviously this is leaving the basis, this is getting into the basis. So y is getting in and S1 is leaving the basis. Moving ahead, this is what we have written from the last, and if you'll observe here, this 6 is the pivot element for this previous steps, because this is getting in, this was leaving out for the basis. Next, or this actually this is a second. This is a second, so this is initial first and this is the second. Now again it's 4 minus 2 0 0. We have got it here, instead of x1 and x2 we are having here this as y and this is x. So we'll be getting here y, the coefficient of y is, sorry, this is x y. Okay, so coefficient of y is minus 2, coefficient of x is 4. So we'll be getting it here the values as minus 2 and 4, and therefore the 6 has to be 1. To get the 6 1, we will be dividing the entire first row as 6 by 6, or this is, so it is 0, it's 1, it's 1 by 6, it's minus 1 by 3, and this is coming out to be 1. Now to get this 2 minus 2 by 3 0 using this 1, the transformation worked as R2 old minus, because it's minus already, so we have to take it plus 2 by 3 times R1 new. So this R1 new, that particular column or this particular row become here 1 0 1 by 9 1 by 9, and this is 8 by 3. Please, my suggestion for you is just pause the video for a while and just try to get the values which I am getting it on the board. Then the Cj minus Zj would be 0 0 minus 1 by 9 and minus 10 by 9. Then this Z, yeah, previously also Z was 8. Let me just explain you that. Z is equals to 26 by 3, because it's minus 2 into 1 plus 4 into 8 by 3 will gives us 26 by 3 for this Z. And in the previous step we have got it here, Z is equals to 4 into 2, that is equals to 8. And the previous step we have got the z equals to 0 here, because we have got this S1 and S2, the coefficient CB's are zeros. This is the reason we have got the values of z over here in the shaded part. So we got it as z equals to 26 by 3 in the particular this step. Now looking at the Cj minus Zj, we have to stop at this stage, because Cj minus Zj's, all of them are less than 0 or they are equal to 0, and we have to stop at that place. No need to calculate this theta column over here. So we have received the solution as x is equals to 8 by 3, y is equals to 1, z max is equals to 26 by 3. But we are not interested in z max, we are interested in z minimum. So z minimum is nothing but negative of this, which is minus 26 by 3. And if you wanted to see this particular question over here, you can check this question like this. This is what is the question for this particular the entire thing. As I've told you, we can solve the entire thing at one go using this one. That's all from this. Yeah, this is, I think, the self-observation from the previous step. I have kept it here, but no, it's not required. Thank you so much. Happy learning.